So, the internet's an awesome thing. You get to benefit from other people's creativity. So I saw this on Facebook and I just had to share it with you. How I see math word problems. If you have 4 pencils and I have 7 apples, how many pancakes will fit on the roof? Purple, because aliens don't wear hats. That makes absolutely no sense, right? But to many people in the general public, that's what math word problems are like. Yeah, you can read it. You can pronounce all the words. It doesn't make any sense. Okay? If you are one of those people, you are in good company, okay? And I can help you. The bad news is that there are math word problems in chemistry. We don't do crazy math in chemistry, not in general chemistry. We do basic algebra, little bit of geometry, adding, subtracting, multiplying, dividing. It's not anything too big and scary. The problem is that most of it is applied to a life situation, a chemistry experiment or something. And so then it necessarily has words involved. So we're going to have a lot of word problems. And you need to take the word problem and turn it into a mathematical equation so you can find the answer. Solving the math equation is usually not the problem. It's deciphering what the words say and getting to the math equation. Okay, if you're good at word problems, this class is going to be a lot easier. And yay for you. Okay, but there seem to be 2 kinds of people, and we're just divided into 2 camps. People who like and understand word problems, we call them story problems when I was growing up, and people who hate story problems, do not understand them. It's a rare person that's kind of wishy-washy about it. You either get them or you don't. And it has nothing to do with your intelligence. It has to do with how your brain works. Okay? The people who don't get story problems are really good at some other things that the story problem people just can't do. I mean, put me in a poli-sci class and I would die. Okay? Oh my goodness, I cannot handle stuff like that. Give me story problems. I'll do story problems all day long. Okay? So you can succeed in this class. You can do very well even if you're not a story problem person. But you're going to have to learn how to do story problems, okay? And I will do my very best to break it down and help you figure them out. And I will match your effort level. I often have students who just never really talk to me all semester. And I'm fine with that because that's the kind of student I was in college. I just sat in the class, but I understood what the instructor was saying, and I took notes, and I did my homework, and I got the answers right, and I did well on the exams. I didn't need to talk to the teacher. I was doing just fine. If you're one of those people, great. I'm not offended if you don't talk to me. If you're a person, though, that's sitting there and not understanding and struggling and failing exams and still not asking for help, then maybe just save all of us the trouble and drop the class, right? I can help you. Oh, well, I'll go to tutoring. You know, there's free tutoring in the Mesa Center. Well, yeah, there is free tutoring in the Mesa Center. And some of those tutors are really good, and some of them are kind of so-so. I'm better than any of those tutors. And I don't think that's being arrogant. I have a master's degree in analytical chemistry. What do they have? They're in their, 2nd year at a community college. And maybe they're going to go on to great things, but I've studied chemistry a lot more than they have. And I've been teaching for a long time, and I've been explaining these things to people who don't understand them and who didn't really want to learn them in the first place for a long time. So try me, okay? You can text me questions, and I'll text you back. I've got a little keyboard that I can use with my iPad or my phone. And so I can type, and it's not painful to, all these words, and I can explain things, okay? So try me. I can help you with this. So what do? So getting to the equation requires critical thinking. That's the hard part. The thing is, there's no simple formula that's going to work for everything. And I think the way a lot of you were taught in school is they taught you how to do specific things. and you became good at doing specific things. Well, ask me to calculate the area of a circle. I can do that. But what if we need to do something a little bit different? So we have to kind of think about it. Sometimes it helps to approach it like you're a detective and you're trying to figure out this problem. Have any of you guys watched the TV show Psych? A little bit? Okay, but not very many people. My husband and I just discovered it. So we're watching it on Netflix. I really like it. But there's this crime. And they're trying to figure out the crime. And they get these little clues. And they keep at it, and they keep at it, and they put it together, and they solve the crime. Solving problems is a lot like that. You look at it, you may not see immediately what you're supposed to do. Don't give up. Puzzle over it. Look at it. Sometimes it's helpful to struggle with it for a while and then go do something else. Your brain is pretty amazing. Your brain will keep working on stuff like that in the background. Come back later and look at it again, and you may find out, oh, I see it now. So don't give up if you don't see it the first time. So no simple formula is going to work for every problem. You can learn problem-solving strategies. Many of the problems that we encounter can be thought as unit conversion problems, and I'm going to show you a technique for that. And there are other problems that require the use of specific equations. Students usually have less trouble with that, because if I give you an equation, it's a matter of identifying what numbers you should put in there, and you just put it in there and you're done, and usually that's not as big of a problem. So we need to learn how to do unit conversions. Units are multiplied, divided, and canceled just like any other algebraic quantity. So A's and B's, X's and Y's, all those letters that you had in algebra. X squared over X, right? That's X squared divided by X. Can we simplify that? Yeah, X squared is X times X, and we're dividing by X. So we've got X over X is 1. That's the same as X. It's those sorts of things we can do with units also. If you're rusty on your algebra, if what I just said there with the X's, you're like, oh no, that's not good. There's a lot of free tutorial stuff you can find on the internet. Go watch some videos on basic algebra. There's some great ones out there. Get yourself back up to speed. We're going to use units as a guide, and this technique is called dimensional analysis. The dimensions are the units. We're going to analyze the units, and this is going to help us solve the problem. I learned dimensional analysis when I was a junior in high school in physics class. And I think it's safe to say that that is the most important thing I learned in high school, was dimensional analysis. That enables you to do all kinds of things, and practical things too. A garden example. So you've got a garden and you measure it, you want to put some manure on it, make the soil better. So it's 10 feet by 12 feet, and you think, oh, I want about 4 inches of manure on it. So you measure the garden 10 by 12 feet, and you go to the garden center, and the manure is sold by the cubic yard. What do? Just buy a couple bags and bring them home and see if it's enough? No, dimensional analysis, you can actually calculate how many bags of manure. You need to give your dog some medicine. Did you know that flea medicine that you put on the back of their neck to keep them from getting fleas, they sell it for little dogs and they sell it for big dogs, and the big dog one only costs a little bit more than the small dog one. It's the same stuff in there, it's just the big dog one has more in each of those little capsule things. Well, you can look on the label and find out how much is in the little one, the concentration, and figure out how much active ingredient. And you can do a dimensional analysis calculation and find out how much of the large one you need to put on your small dog. We do that with our cats. One package for a 55-plus pound dog will last 2 cats for months and months and months. It's awesome. It saves you a lot of money. Dimensional analysis. Lots of other things you can do with it. So when we're doing dimensional analysis, this is important. Always write every number with its associated units. And this kind of duplicates that statement. Always include units in your calculation. The unit is part of the measurement. Remember that sentence, when my son was 7, he walked 3. Okay, when you do that in your calculations and leave the numbers out, you're going to get wrong answers. And pointing in the wrong place, do not let the units magically appear or disappear. Treat them like variables in algebra. I see this sometimes, students will, and then they'll even draw lines here, like you're crossing it out, these cancel out. I'm like, centimeters times centimeters don't cancel out, those are multiplying. I call that wishful unit cancellation. There's no magic involved with units. So for most conversion problems, what we have is that we're given a quantity with one particular unit, and we're asked to find that quantity in another unit. So they take this form. The information given will be multiplied by some sort of a conversion factor, and then we'll get the information that's desired. So the given unit times the conversion factor. The conversion factor will look like this. It'll be the unit what we're trying to find divided by the given unit. And what happens is the given units cancel out. So let's just do a concrete example here. How many feet in 100 yards? And most of you could probably do that in your head. And these initial examples are going to be units that you're familiar with. But later in the semester, we're going to be dealing with grams of hydrogen and moles of sulfuric acid. And just knowing how to do it isn't going to work. So we're going to look at the process here with more familiar things so that we can learn the process and apply it to things that are not familiar. So what is the given unit in this question? 100 yards. Right? It's the unit that has the number. How many feet are in 100 yards? Well, 100 yards is what we're given, and what are we trying to find? The number of feet. So our equation is going to look like 100, sorry, not feet, I did that this morning too, 100 yards, and then we're going to multiply, and we're going to put the unit that we're trying to get on top and the unit that we were given on the bottom. Because we want the yards to cancel out. A yard divided by a yard equals 1. Anything divided by itself equals 1. X over x equals 1. Centimeters over centimeters equals 1. 42 over 42 equals 1. Okay, basic principle of math. So we have our units in here, and that's what we do in dimensional analysis is we put the units in first. The units tell us whether we should be multiplying or dividing. Because you may know that the conversion factor is 3. There's 3 feet in a yard. Do you multiply the 100 by 3 or do you divide? Well, if we think about it, we can just figure it out. But the common mistake is to do the wrong operation. So let's look at this. We've got feet on top and yards on the bottom. The relationship is 3 feet equals 1 yard. The what this works out to be, it's a quantity that equals 1. The top equals the bottom. So we're really just multiplying by 1. So we're ending up multiplying by 3 feet. 3 feet, and we end up with 300 feet in 100 yards. Any questions? We're going to talk more details about the process. That's just kind of a overview example kind of deal. Where do those conversion factors come from? Well, you can construct one from any two quantities that you know are equal. You may find them in a table. This table, table 2.3, is in your textbook. It's very useful. It gives a lot of relationships between different units. For length, it gives a relationship between kilometers and miles, between meters and inches, meters and yards, feet and centimeters, inches and centimeters. It's not giving you the relationship between feet and yards because that's assumed to be common knowledge. I would assume that you know there are 12 inches in a foot and 3 feet in a yard. I would not assume that you know 5,280 feet in a mile. If you need to use a weird conversion factor on an exam, I will give it to you. The ones in this table are not ones that I would expect you to memorize. Okay? This is an exception, but this is one where we're using the metric prefixes. So the other way we can get conversion factors is using those SI or metric prefixes, and we'll learn how to do that. One on here that would be worth remembering, because it gets used quite a bit, is the relationship between inches and centimeters. An inch is 2.54 centimeters. And notice it says exact. Okay, we've talked about significant figures and what exact numbers are. Conversions within a system, within the metric system, meters to kilometers, or within the English system, feet to inches. Those are exact, they're defined. Conversions between English and metric system, most of those are not exact. So this one between kilometers and miles, 1 kilometer is 0.6214 miles. That would be considered to have 4 significant figures, and that could potentially limit your significant figures in an answer. 1 inch equals 2.54 centimeter. That's an exact conversion factor. They actually redefined the inch so that it is exactly 2.54 centimeters. It's defined that way now, so that one's exact. I told you not to go to sleep. So let's put together some conversion factors. Feet and inches. 1 foot is how many inches? 12. Who said, wrong color. 1 foot equals 12 inches. So that's an equality or an equivalence statement. A conversion factor is going to be a fraction. A friend of mine teaches middle school math. She tells her students, or she tells me her students feel that fractions are the F word. Fractions. We're going to deal with fractions. They're not that bad. So 1 foot equals 12 inches. If I divide both sides by 1 foot, is that still equal? Yeah. If I took a teeter-totter that had 2 children on it and it was exactly balanced, and I gave each child an 8-pound bowling ball, would it still be balanced? Yeah. Because I did the same thing to both sides. Math equations are kind of like that. If I give the bowling ball to just one child, is it still going to be balanced? No, it's going to tip. So here I divided both sides by 1 foot. It's still equal. 1 foot divided by 1 foot, what does that equal? That equals 1. Anything divided by itself is 1. We say those cancel out. 12 inches divided by 1 foot is numerically equal to 1. What if I inverted that and said 1 foot over 12 inches? It's the same thing. That is also equal to 1, because 1 over 1 is equal to 1. All these conversion factors are just a funny way of writing the number 1. The top equals the bottom. Let's look at inches and centimeters. 1 inch is how many centimeters? not 10. It's 2.54. Oh yeah, that's right. What was I thinking? Okay. 1 inch equals 2.54 centimeters. So what are the two conversion factors that we can write from that? Well, we looked at it one way up here. Here's another way to look at it. Think of this as the fraction line. And we could tip it this way. That's supposed to be an arrow. And end up with 1 inch over 2.54 centimeters. Or if we tipped it this way, you see what I'm talking about? You take the, and you just tip it so that line's horizontal. I forgot the centimeter. Or we can tip it the other way and get 2.54 centimeters over 1 inch. So from any equivalent statement, two things that are equal to each other, you can make two conversion factors. You can put either one on the top. It doesn't matter because they're equal and the whole thing is equal to 1. So when we're solving problems, these are some tips. Always make sure that your final units are correct. Sometimes students do some wonderful calculations, but they calculated the wrong thing. That's not what the question asked for. Make sure you're ending up with the right units. Always consider if it makes sense. Does the magnitude, the number part of the answer make sense? If you're doing a calculation and you are trying to find the number of people that do something and you come up with 0.27 people, is that possible? No. You know, how many people like Flaming Hot Cheetos? And you do this big calculation, you come up with 0.27 people like Flaming Hot Cheetos. That's ridiculous. You can't have less than a person, right? So sometimes, if you think about it, it will be obvious. Yes, that's reasonable, or no, that's insane. That's completely impossible. So always look at your answer. And like I just showed you, conversion factors can be inverted. That means tip it upside down because they're equal to 1. And when you tip 1 upside down, it's still 1. Have any of you watched Dora the Explorer? You don't need to be ashamed. It's a good show. I've watched a lot of Dora the Explorer. Who do we ask when we don't know which way to go? The map, right? We need a map. The map tells us where to go. We're trying to get to the Snowy Mountains. And the map says first we have to cross the Roaring River, and then we have to go through the Scary Forest, and then we'll get to the Snowy Mountains, right? And then they chant it, right? Roaring River, Scary Forest, Snowy Mountains. And they do it several times, right? We can apply Dora the Explorer to solving unit conversion problems. We need to identify where we are, where we're going, and how to get there. And then it's a great idea to write that down. Just very simply, we don't have to draw a fancy map with pictures or anything, but just to have it written down so that when we forget where we were going, because I'm sure all of you have had this experience, you go into the kitchen and you're like, why did I come in here? Fine. You go back to your bedroom, oh, that's right, I needed a glass of water. I used to live in a 2-story house when I was growing up. And I'd go upstairs to my bedroom, can't remember. And it's not just old age, because, I was 15. And I'd come downstairs, and then I would remember. And so up and down the stairs, up and down the stairs. And that happens when you're doing a math problem, too. You're focused on this little part, and then you forget where you were going. If you have the map written down, you can go look at it. Oh, that's right, I was trying to do this. Because we don't actually have a little map that'll pop out of our backpack and tell us what to do. Sometimes that might be nice, though. So the map is going to focus on the units and how to convert one to the next. So here's an example of solution maps. Very simple things, and you don't need to draw pretty little boxes like this. So the solution map for converting inches to centimeters. Well, we're starting with inches, and we're going to convert to centimeters. We know the relationship, and so this is just a one-step process. But we're starting here, we're going there. This is the conversion factor that we're going to use. If we're going to do the opposite, if we're coming from the snowy mountains back to where we are, we're going to do the reverse process. It would be centimeters to inches, and the conversion factor would be upside down. So if you're writing out your map, it's going to look something like this. Okay, I'm starting with inches, and I'm going to go to centimeters. That's what I'm calling a map. It's just units with arrows in between. So general problem-solving strategy. Identify the starting point. You need to know where you're starting. So you read the problem, and sometimes, especially in these simpler ones where it's just about converting a unit, they're going to give you one number with a unit. That's where you start. And then they're going to give you some other unit, and they're going to say, how much is this in that? And so you start with the one with the number, but you have to figure out, where am I starting? And you have to figure out, where am I going? Where am I going to end up? What unit do they want me to find? If they're saying, find out how many centimeters are in this many inches, and you find out how many feet are in that many inches, well, you may have done it beautifully and correctly, but that's not what the question wanted, and so then it's wrong. And then figure out how to get there. Some of these are just one step, and other ones are 2 or 3 steps, like in the Dora episodes. So figure out how you're going to get from one point to another. 2 people doing the same problem might go different paths. There's no problem with that. For many of these unit conversions, there are multiple ways to get there. Like from here going to Fresno. Well, let's say Reedley. From here to Reedley, which is where I live, there's different ways to go. You can go up, I forget the number of the road. Once you get to Fresno County, it's called Alta Avenue. But you go down 198 here, and I think it's Plaza Drive. You take that, and you can drive up through Dinuba and get to Reedley. I don't like that. I go over to 99 and go up to Traver, and then there's this little wiggly thing you go through on these really nice back roads where there's almost no traffic and not very many stop signs or anything, and it's a lot faster. 2 different ways to go from point A to point B. Could you also head south from Visalia and just keep going? You could. You could go south from here. Reedley's north. You could go south, and you could go all the way around the globe and come at Reedley from the north. Would that be efficient? No. But if you got there, you got there. Lots of different ways. Sometimes there's a much easier way and a much harder way. But the way that you go is going to depend on what is given. Let's see if I can find these words in here. Using what is given, as well as what you know, what you already know, or what you can look up. So like on an exam situation, a unit conversion, you're going to be limited to any conversion factors that I happen to give you, plus the things you know, like the metric prefixes and what they mean. And so you'll have to use those parameters. So like, converting inches to miles, I could probably find it on the internet if I looked hard, but what's the relationship between inches and miles? I don't know off the top of my head. But I could go inches to feet and feet to miles because I know those. So sometimes you have to take an intermediate step. So use a solution map to diagram the steps. So that's this given thing and what you're going to find. And sometimes it's one step, and sometimes it's more than one step. So sort, strategize, solve, and check. Sorting. You read the problem all the way through, then go back and pick out the numbers. And I'll tell you these steps as we go along and as the problems get a little more complicated. But you got to sort the information out. And it really helps to pull the numbers and the units out to get them away from the clutter of those other words. Strategize. This is where you say, okay, this is what I'm given, this is what I want, how can I get there? You write down the map. Then you solve. The solving is usually fairly easy. That's the math. We're going to use calculators. And then check. Look at the answer. Does that make sense? Is it possible? If I calculate the distance between here and Fresno in inches, and I come up with 542 inches. Is that reasonable? No. Inches are really small. 500 of them probably wouldn't even get to Mooney. Okay? It's not going to work. So always check. That can save you points by pointing out a wrong answer. So let's do some examples. Convert 56.0 centimeters to inches. So what do we have here? Well, we've got 56 centimeters and we've got inches. So there's two units here. One's going to be the given unit, one's going to be the desired unit. Where are we going to start? With the centimeters, because that's what we are given a number for. We're going to start with centimeters and we're going to convert to inches. Do we know a relationship between centimeters and inches? We've talked about that a couple times today. 2.54 centimeters equals 1 inch. So it may be helpful over on the side to write down that relationship. 2.54 centimeters equals 1 inch. Some people like to do that ahead of time, other people don't need to do that, and that's fine too. So I've sorted out, I've strategized, and I'm going to solve. So I'm going to write down 56, that didn't turn out very well, 56.0 centimeters. How many arrows are in this map? 1. I'm going to have 1 fraction. Later we'll see some that have 2 or 3 arrows. Then you need 2 or 3 conversion factors. We're going to have 1 conversion factor, and this is going to equal something. The map up here tells us what the units are in the numerator. The numerator is the top of the fraction. Centimeters to inches, so that means in the numerator here, centimeters to inches. So inches is going to go here. I want to get rid of centimeters. Centimeters was what I was given, but I need to get rid of it. We get rid of it by dividing so that it will cancel out. Centimeters divided by centimeters equals 1. And so we say, poof, you're gone. So I'm going to cancel those out. I'm left with inches. Dimensional analysis, you look at the units. The units tell you what to do. Now we need to put in some numbers because an inch is not the same as a centimeter. So then we look at this relationship and we see 2.54 centimeters is 1 inch. So the 1 goes with inch and the 2.54 goes with the centimeters. Then we use the calculator. This is 56 divided by 2.54. Calculator says 22.047241. And the unit on that is inches. See, I've got a number and a unit, a number and a unit, a number and a unit, a number and a unit. We're not going to have any numbers left hanging by themselves. When you do this on your calculator, some students prefer to do 56.0 times 1 divided by 2.54. That's fine. Other students say, I don't need to multiply by 1, that doesn't do anything. and that's fine too. You'll get the right answer either way. This is what the calculator says. Is that our best answer? No. Not the right number of significant figures. So we're going to practice sig figs continuously. How many sig figs in this measurement? 3. Trailing 0 with a decimal point. So that's got 3 sig figs. What about this guy? That's one of those rare exact ones. Exact, so we could say that they have an infinite number of significant figures. Basically, we can just ignore that in terms of numbers of significant figures. So if we started with 3, we'll end up with 3. So should be that 0. So we should say 22.0 inches. Is that 0 important? Do we really need to write the 0? Yeah, we do. Because when we write 22.0, we say there's uncertainty in the tenths of an inch. If we write just 22, there's uncertainty in the ones place. That's a lot more uncertainty. Okay, so we're going to care about those zeros. Any questions about that example? Let's do the next one. Convert 5,678 meters to kilometers. We have 2 units. One has a number, one doesn't. The one with the number is where we're going to start. So we're going to go meters, and we're trying to get to kilometers. Can we go directly from meters to kilometers? Yeah, we can. Some of you may be unsure, and that's fine. I'm going to show you how. So we're going to go from meters to kilometers. So then we start setting this up. 5,678 meters. There's one arrow in our fraction. There's one arrow in our path. And so we're going to have one fraction. And that's going to be equal to something. Meters to kilometers. So here we're going to have meters and kilometers. Meters to kilometers. We want the meters to go away. We need to divide by meters. Because meter divided by meter is 1. Poof! It's gone. So our units are in place. Now we need to put a number in there because a kilometer is not the same as a meter. And in these conversion factors, the numerator, the top, has to equal the denominator, the bottom. What does kilo mean? Kilo means 1,000. So K means 1,000. Means 10 to the third. I'm going to be consistent and use 10 to the power. If you want to write 1,000 down, that's fine, but I'm going to be consistent. So looking at this, here we have kilo, meter. Kilo is 1,000. Kilo multiplies meter by 1,000. We're going to put what kilo means down here with meter. We're not going to put it with the kilo. So we're going to put the 10 to the third down here. And I drew those too close together, so I need some sort of dividing line here to make sure that they're not getting mixed up together. So let's look at that in a little different way over here. So I want my conversion factor to equal 1, right? So 1. So if I have meter over meter, does that equal 1? Yes. If I put kilo on the top and meter on the bottom, does that equal 1? No. I need to put what kilo means on the bottom. If I put kilometer down there, that would be equal to 1, right? But that's not very useful, is it? So if I put what it means Kilo means 1,000. It's like a nickname. My third son, his given name is Thomas. We never call him Thomas. We call him Tommy. So Tommy is like the metric prefix. It's the nickname. It's the short version. And the meter is like the last name. So kilometer, KM, is like Tommy Kawagoe. But the given name is Thomas Kawagoe. What it means is 1,000 meters. There are different ways of naming the same. The common mistake is that they put the number in the wrong place. So if you follow this pattern of using 10 to the third for K, and you don't ever put them together, because Thomas Tommy Kawagoe, why would you call him that? You're going to call him one or the other. Okay, quick before the iPad dies, because we're down to 10%. We're at critical mass here. How do we do this in our calculator? 10 to the third. All those 10 to the somethings, what do we do? Well, what if we just put a 1 times in here? Yeah, I realize I switched colors. Does that change it at all? No. Does that make it look like scientific notation? Yeah. So we can enter those numbers as scientific notation. So we're going to take 5,678, 5678, divided by 1 EE3. And you're going to get 5.678. Kilometers. Try it. Remember, to enter that, it's 1 EE or EXP 3. EE stands for times 10 to the. So as you're putting it into your calculator, you go 1, and as you press the EE button, say times 10 to the 3. Because the common mistake there is people go 1 times 10 EE3, and then you mess everything.